Hello. Hi, Renee.
Hi.
Hi, everyone. Let's give them some time to connect. Still one. Are you ready, Renee?
I think I am.
Okay, I think maybe we can go ahead and start. Okay, so welcome everyone to our webinar. Thank you so much for joining. It's really a pleasure to have all of you connecting in from all time zones. So today's webinar is about the ultimate checklist for preliminary engineering documentation. So you'll be able to discover what are the basic documentation that will be able to assist you in feasibility analysis and conceptual designs. Today, I'll be your host, Ghada Alafranji. I'm the account executive at RatedPower. I've been working with RatedPower for a long time now, and I manage the MENA region, Turkey, and India. So it's a complete pleasure from my side, and I'm accompanied today with my colleague Irene Negra-Torres.
Well, hi, hello. Nice to meet you, everyone here today. I'm Irene Negra-Torres, as I was saying. I'm the customer success manager. I work for the customer success team. We provide support to our users, and I specifically work for the LATAM, Spain, and the India market also. So nice to meet you, all of you today here.
So our agenda for today is the session will be for 45 minutes, and it will start off with the ultimate checklist for preliminary engineering, giving an introduction, and then my colleague Irene will give you the showtime. So she will be presenting to you the most crucial documents that will help you in preliminary analysis stages. And then lastly, we all love questions. We'll have a Q&A for about 25 minutes. So feel free to share your questions during the webinar and presentation. The questions box, and feel free to do them in the end. Okay. So for those of you who don't know RatedPower, we are the developers of PV Design, a comprehensive software package to instantly carry out the design and engineering of a utility scale photovoltaic plant. What are key benefits of PV Design? It's to reduce time, increase the accuracy, and easily to compare between your documents and the project designs you've created. My colleague Irene will go ahead and share with you the documents. So over to you, Irene.
Okay, thank you. Thank you, Ghada, for the presentation. So let's share my screen now. Okay. Okay, so now we are inside PV Design. What we are going to do today is to see all the different documents that the software generates. So here we are inside a project now. So let's click on one of the designs that we have generated with the software. We have gone through a design process in order to design this specific plant here. And what we can see regarding all the documentation, it's here. What the software generates, it's a bunch of engineering documentation that will help you to develop your project. So here you can see the list of all the different documents that the software generates for each of the designs that you generate within a project. And we will stop in a few of them. We will see them, we will analyze them, but as a summary, you'll find some different reports, a design report, an energy deal report, the interconnection facility, also an overhead line report in case you add the overhead line to the layout of your plant, a battery energy storage system report in case you are working with an AC coupled system, some spreadsheets such as the project sheet, the bill of quantities, a financial analysis, of course, the energy deal results. And then we have some drawings such as the general layout, a 3D layout of the plant, some single line diagrams regarding the electrical configuration of the plant. And then we have also the topography analysis and structure profiles. Okay, so let's start with this documentation. Let's see first. Let's open the general layout of the plant, which is actually this layout that we can see here that the software automatically generates for us based on some parameters that we have defined during the design process. Okay, so I have it already here. I just download it. If you want to download it, you just have to click here and you can download it. Okay, so let's open it in AutoCAD with the DXL file. And let's see in detail this general layout document that can help you out understanding and seeing the final result of the PV plant. Okay, so basically here in this general layout, what we can see in AutoCAD, it's all the different layers here that compose this general layout. Okay, so let me just move this a bit here and let me go back to the layers. So as you can see here, there are different layers in case we want to see how the different trenches are located, also the different cables, both the low voltage cables and the medium voltage cables, the fence, the roads, the structures. So all that information regarding the equipment of our plant, the power stations, we'll find it here in the general layout. So in case, for example, I would be interested in also seeing the string cables, I would just click here for the 6mm string cables and here, and I will be able, if I zoom, to see these different little cables. Okay, so here I will see the trenches also, the string cables. So it's a detailed layout of our final design. Okay, so for example, here I can find also the location of the different power stations. If I go here, I'll see the substation, and also in case I'm working with the battery energy storage system, I will also find the layout, the basic engineering, and the interconnection of that battery energy storage system. So, so yeah, this is one of the most interesting documents that the software generates, because it can help you to completely understand how all the final design is connected. Okay, so let's go back to PV design. And let's see a different document here. So now what we are going to see is the design report. As I was saying at the beginning, the software will generate different reports that summarizes all the information regarding our design, the energy yield, where we'll find the specific information regarding energy. But we are going to see today the design report. So let's go to the design report. You have it, this document in two formats. So in case you need to change anything or modify anything in these documents, you'll have the editable format, so you can change anything that you need. Okay. So let's go inside the design report. As I was saying, so what are we going to find in this design report? So we will find a summary of our plan. So we start here with the well, an introduction of our plant with the main characteristics, the location, rated power, peak power, the civil characteristics, the electrical characteristics also. And then we have some more information regarding the site, the location, where we are developing our project or our plant. Also, not only regarding the site, but we find information regarding the radiation and the solar data that we are using, or meteo data. We also find the main equipment that we are using for this specific design, the inverters, the modules, power station configuration. So we'll find all this information here. And finally, we have some information regarding the sizing of our plant. Okay, so this would be a kind of a summary of our plant and of this specific design that we have done. Okay, so civil works, and then finally the electrical configuration and trenches of our plant. So this would be another interesting document in case you would like to have this summary of the plant. Okay, so let's go back again to PV design, and let's see, let's analyze also another document here, which would be some spreadsheets. Okay, so let's start with the bill of quantities, because the software will also generate a bill of quantities with all the different equipment that you need in order to develop that specific plant. Okay, so let's see the bill. So it's this one here, the bill of quantities. You'll find the PV modules, the number of structures, the number of inverters. So basically the main equipment of the plant. Also the civil works here, in case you have applied any earthworks, because in the software you can do a topography analysis of the plant, and you can apply earthworks in case you would like to install more structures. Okay, so you'll find also information regarding those civil works that you apply. Here in grubbing, topsoil and vegetation removal. Then we have also the information regarding all the electrical configuration of the plant, the trenches, manholes, so, and the electrical system here with all the different information regarding the cabling system of the plant. This would be the PV plant BOQ, or bill of quantities. Then you also have the bill of quantities for the substation, so all the elements regarding substation, transformers, and all the electrical configuration of the substation. Then we have also the battery system BOQ, in case you have added this battery energy storage system into the plant. And finally, in case you are also designing with an overhead line, you'll also find the bill of quantities for that overhead line regarding the towers and the conductors, insulators, all the elements regarding this overhead. Okay, so let's continue with this documentation that the software generates. Let's see another Excel sheet. In this case, we are going to analyze the energy yield results. Of course, one of the most important results here. So in this Excel sheet, in this energy results, what you'll find first, it's a summary of the PV plant, the rated power, peak power, main equipment, location, meteorological data, the energy yield, also the probability studies, P50, P75, P19. So you'll have all this information gathered here, and then you'll have, or you'll find in this document, the hourly production throughout the whole years of simulation, year 1, year 2. So we have the energy production per hour in this case. We have also the consumption of the plant, and also the losses here per year. So you'll find all this information in the energy results Excel sheet. As I was saying, this is a editable format, so in case you need to change anything from this document, you can directly do it here in this Excel sheet. Okay, and then let's continue with the analysis of these different documents that this software generates or provides each time that you generate a new design. Okay, so let's go now for the electrical configuration of the plant, because this software will also provide some detailed electrical information regarding the plant. So you can find it here. So you can find, for example, the medium voltage single line diagram, low voltage single line diagram, and of course the low voltage medium voltage SLD also, and the SLD for the interconnection facility. Okay, so let's take a deep look into the single line diagram, the medium voltage, low voltage single line diagram. Okay, so we have the example here. I'll zoom a bit. Well, I'll show you how it looks like this document regarding the electrical topology of our plant. But let's zoom a bit, so let's see it in detail what PV design provides us in terms of the electrical configuration. Okay, So of course, this depends a lot on what the user has defined during the design process. So you have some inputs, you can define the number of models per strings, the number of strings per structure. So based on that, and based also on the DCAC ratio that we have, that we defined, and the inverter characteristics, we will provide you with this single line diagram. So as I was saying, let's zoom a bit and let's see it in detail. What can we find in this single line diagram? So as you can see here, we find the models per string. In this case, it would be 24. As I was saying, this is an input that the user defines for their specific designs and projects. Then we have the number of strings here, the string box configuration. We can find different string box configurations here. Then we finally find the inverter. This inverter, it's the inverter that we have selected during the design process inside the software. And we finally find the medium voltage transformer, which is sized based on the inverters that we have selected. And finally, we will be connected to the power station. So the different power stations configurations we'll find here in the single line diagram. So it can help us understanding the electrical configuration or electrical topology of our plant. And as I was saying, you will also find the low voltage single line diagram in case you would like to have more detail in terms of models per string and strings per structure. You'll find more detail in the low voltage single line diagram. And in case you would like to have more detail in terms of power station and medium voltage configuration, you will also find the medium voltage single line diagram. So this one would be like an overview of both configurations at the same time. Okay, so let's go back to our list. Okay, as I was saying, with all of these documents, you can download them in an editable format. But here we have also another interesting document that the software generates, which is the PV Collada file. This PV Collada file, it's a file that you can import into PVSys. So that way you'll be able to do the 3D shading analysis in PVSys. So this PV Collada file, it's a 3D scene of the PV plant, okay? Because as you can see here, the software generates not only the general layout that we were seeing before, but also a 3D layout of the plant, where we can see the topography, the terrain characteristics, and how all the structures are placed or are fit in our plant. Okay, so this PV Collada file is specifically for PVSys. Okay, it's the same 3D layout that we can download for AutoCAD, but we can export it and then import it later into PVSys to do that 3D shading analysis into PVSys. So it's directly related to that. And it's interesting to do that analysis there to see how it affects the 3D shading and the terrain ondulation to our plant. Okay, so this would be like a summary of the main documents that the software generates. As you can see, there's this whole list. This set of documents that it's the most added value that the software, or one of the most added values that the software has, but the ones that we have gone through, like like diagrams, the general layout, the energy yield result, or even the design reports, are one of the it's for you to make you an idea of what the software can provide in terms of engineering documentation. And this would be like the whole list that the software provides. Okay, so okay, Ghada, I think now maybe it's time for before the questions. I don't know if you would like to add something to the presentation. Let me just okay.
It was immaculate. Thank you so much, Irene, for your presentation, for sharing with us where the ultimate checklist for the preliminary engineering documentations. We really appreciate it. So we'd love to hear more about your questions and your thoughts. Now that you've known what is the preliminary analysis that you can get from PV Design, how it can assist you in either the feasibility analysis or conceptual design, or even requesting for proposals, just with these basic checklists that you can achieve all of the following. So we already have time for Q&A, and we already have 2 questions by Taha Hussein. The first one is to you, Irene. Am I right that PV Design works on a flat terrain only? So all data, for example, in the DXF file will be valid only for the flat terrain?
Okay, so no, PV Design also works with more accidental terrains or high terrains. So so you can work with any topography, because the thing is that in PV Design you can upload your own topography data, and you can work with that data, and you can make the topography analysis directly in the software. So regarding this topography, inside the software you'll find the data from Google Earth, so you can directly use the one from Google Earth, and we will be considering the slopes and the terrain ondulation for the topography analysis. But of course, you can work with your own topography data that you can upload to the software, and we will be considering that topography data for the topography analysis. Because as I was saying, there are some specific documents regarding this topography analysis, such as the structures profile, for example, and you can also apply earthworks, as we were seeing before in the bill of quantities, that we have the total Ghada field volume there. So all this topography analysis will be based on the topography data that you upload. So of course you can work with flat terrains, but you can also work with high terrains in the software, of course. So thank you for the question.
Second question, what does it mean by PV Colada? So could you elaborate more on PV Colada and what it does?
Okay, yeah, of course. So basically, this PV Colada file, it's because although you can do the topography analysis directly in PV Design, and we will be considering the terrain slopes and terrain ondulation. This shading analysis that PV Design does, it's a 2D shading analysis. So this PV Colada file will help you doing the 3D shading analysis in PVCs. So what the software is doing is helping you by generating this layout already in a 3D scene. So you don't have to define it in PVCs, which would be a more slower process. So you can directly download this PV Colada file from PV Design. So it will be exactly the same plan that you have designed in the software during the design process. So you will get this 3D layout from the software and directly import it into PVCs to do the 3D shading analysis, in case you are interested in analyzing this 3D scene of the plant and the shading of the plant based on the terrain ondulation. You can do it directly in PVCs. So what we were trying is to save time in the end, because if not, you would need to go to PVCs and define the whole plan there. So by taking this PV Colada file, you can do it directly in PVCs by uploading the 3D layout of the plant, of the same plan that you have designed with PV Design.
Wonderful. Thank you, Irene. And the next question is by Frank. Are the cable lengths then included in the 3D terrain?
This question is regarding is cable lengths are considering the 3D scene of the plant?
Correct, the 3D terrain.
So okay, good question here. When we are calculating these cable lengths, we are considering the terrain of the plant, but we are not considering the vertical when they are varied, because medium voltage cables, they are buried, okay, so they go into trenches. When we are giving these cable lengths, we are not considering that vertical part of the cable. We are just considering the horizontal, but because it's not well, we could do it, but we are not we are calculating the cable based on the horizontal path of the cable, and it's quite same length that it would have if we would be considering the vertical that vertical side of the cable. But for now, we are not considering like these differences in terms of height. But yeah, in terms of cable lengths, it's like an accurate approximation of the real cable lengths of the plant. But maybe you could consider an extra 2% in order to consider that vertical part of the cable that we are not considering when giving the cable lengths in the bit of quantities. Okay.
Thank you, Rene. So next one from Tujarko. Which kind of shading losses are covered by PV design itself? Is row-to-row shading included, or has PV to be used for this?
So, okay, the question is regarding shading, right?
Yeah, so what shading losses are included in PV design, and is row-to-row shading included?
Okay, so the shading that we are including are, can I share my screen again, Ghada, so we can see the shading that we have, that we include, okay. I'll share my screen, and we can see the shading that we are including in the design process. It's part of the results. So this shading, the software will automatically calculate them based on the structures and the position of the structures and the pitch distance between structures. So you'll find two different places where you can check these losses. You can check it directly here in the energy tab. This is part of the results of this design. Okay, so if we go here to the energy tab, you'll find the summary of all the losses here. Okay, so we are considering near shading losses. So basically, it's the losses because of the geometry of the structures and how they are located within the plant. Okay, so it depends on the pitch distance that we select during the design process, and then, well, in case we are simulating with bifacial, we will also find some phase losses. And then, of course, we will calculate the electrical system losses here, okay? So some of them, you can manually define them during the design process, such as the model degradation, and some of them will be automatically calculated or given by the software, such as the array shading losses. In this case, it could be 0, but in case we are simulating with fixed structures, it would probably be a bit more than 0. Then we also calculate, or we are consider the inverter losses at the inverter level, okay, both for the voltage threshold and also for the power, so the overpower at the inverter level, and then we have the wiring losses here. Okay, so all these losses are automatically calculated by the software. Okay, and then you'll find these losses also in the energy yield report here. Okay, so regarding the shading losses, okay. Regarding the shading losses, we are calculating far shading losses based on the horizon, near shade is on global based on geometry, and also the array shading losses. Okay, in case you are simulating with fixed structures. But in case you would like to consider any other losses or the undulation of the terrain, that's the aim of the PV Colada file. In case you would like to consider as 3D shading scene, you would need to use this PV Colada file. That's the aim or the goal of this document. That will help you to do the 3D shading analysis, because although we are calculating or we are considering these losses, these losses are based on a 2D model. So in case you would like to consider the 3D layout and the terrain of undulation of your plant, you would need to upload this PV collage file into PVSys. So that's the aim of the document, that it can help you to calculate or to obtain the 3D shading analysis of the plant. Okay. So okay, Ghada, let me just here. Okay.
Thank you, Renee.
Okay. Okay. Any more questions?
Yes, so the next one is, what is the accepted percentage of error in calculating the bill of quantities for the project items at which it is extracted from the software tool?
Okay, so regarding the bill of quantities, may I share again so we can just take a look at the bill of quantities again? Okay.
Of course.
Okay, thank you. I'll share my screen again, and we can go to the bill of quantities so we can take a deep look on it. Okay, so here. Okay, let's go to the bill of quantities. Let's go to the bill of quantities PV plant here. So, okay, the different quantities that you'll find here are based on the parameters that you defined. So it depends a lot on if you are maximizing capacity or if you are specifying the capacity. So based on that, we will calculate the main equipment, okay, the PV models, the structures, the inverters. They are based on electrical configuration, DC-AC ratio, and how much capacity we want to install in our plant. Okay, so based on the capacity, on the peak power and rated power of our plant, we will provide the specific number of models, structures, inverters, and power stations that you need. Okay, this would be the main equipment in the bill of quantities, and then, for example, for the civil works, this is, for example, the clearing and grubbing or the topsoil and vegetation removal. All these quantities are based on estimations that we do. Okay. So in case you would like to check exactly from where all these quantities come from, we have a methodology, bill of quantities methodology, where you can check where all these quantities come from. As I was saying, for example, in terms of civil works, these two first, clearing and topsoil vegetation removal, these are based on estimations. But for example, the earthworks are based on how many gallon field volume do we need in order to install a specific number of structures, and for example, this earthworks volume are based on the topography analysis that we do inside the software. Then we have the trenches. The trenches length. It's based on the cables length, and the volume of those trenches are also based on estimations that you can find in our bill of quantities methodology. You can check it in our knowledge base. It's public, so you can take a look there. And then we have also the electrical system, which is basically the quantities that you find here in terms of cable lengths are based on how we are placing or how we are distributing the different electrical system and electrical cabling throughout the plant. And that electrical distribution is based on trying to minimize cable lengths. So this is how we calculate all these different quantities regarding the elements. Then I don't know, the weather stations or monitoring systems. These are also based on estimations, but the main equipment and the cables are based on the capacity that we are installing and on how we are designing our plant and our final layout. Okay, so this would be how it works with the bill of quantities. Okay, Ghada. Oh.
Thank you, Renee. That was really insightful.
Okay.
So I'll go ahead and answer this one from Dominica. Dominica asks us, does it mean that PV Design is not able to provide the same output data as PVSys, or giving inputs takes more time in PV Design rather than in PVSys? To keep it simple and short, PV Design not only does it provide you with the energy yield model, but we also provide you with a set of documents that will help you in either the stability analysis, conceptual design, or requesting for proposals. These set of documents, as Eleni showed us earlier, they can go from the preliminary stages of the plant design of a ground-mounted utility scale system, or it can go into more details. Into the more details, you'll be able to find the PV Collada, which will help you to export your design in 3D to PVSys. That will enable you to carry out different steps of the process, but you'll be good to go with PV Design's data. So with PV Design, it will offer you the energy yield result and the energy yield report, which is crucial part for the requesting for proposals. And not only that, but you have the general drawings, the single line diagrams, and the Excel sheets that include the bill of quantities, listing of cables, and everything that you need. And in sum, basically, PV Design takes up to 2 minutes to do the generation of the project. So you will not be taking a lot of time when you do the engineering process to generating your design. So that will save you so much time when you're looking for a quick stability analysis study, or if you want to go more in details, it will not take that much. And then we have the second question by Riche. What is the selection of documents for the documents package based on? Do you follow some kind of public standard for this, Irene?
Yeah, of course. So it depends on the document, but of course, may I share my screen again?
Of course.
So I'm sharing a lot, but okay, thank you.
No worries at all. Thank you.
Okay, so I'll try again. Let me go back to PV Design. So basically, we are considering different standards depending on what we are calculating, right? So for example, for cable sizing, okay, let me just show you here. On all documentation, we will also generate a listing of cables, right? That you can see here. It's also another spreadsheet that the software generates this listing of cables, and in that listing of cables, what you will find is all the different cables sized within the plant. Okay, so the string box to inverter cables, the string cables, the medium voltage cables also. So how can we size those cables? So basically, it's based on the standard that you select. So during the design process, you'll find an option to select a standard. So for example, you'll find the IC standard or the next standard, also the Australian standard, the Chinese standard. So based on that standard, we will size the different group of cables of the plant. Also, for example, for sizing the substation, okay, or the interconnection facility, you'll also find an option to select the standard that you would like to be based on. So for those calculations, we are considering the standard. There's some other parts or some other quantities or parameters where we are considering standard. For example, when talking about modules per string, okay, you can also define that value as an input, but the software will recommend you a value based on the minimum historical temperature. So this is based on another standard, okay? So, or for example, I don't know, for the modules model, we are using the one direct model. So all this information, we have gathered it in different methodologies, the electrical methodology, the energy deal methodology. So in those documents, in those methodologies, you'll find detailed information regarding the standards that we are using, the models that we are considering for all the energy deal results and calculations. So everything it's there in the methodologies, but of course we are considering different standards and different models to provide you with all these results. Okay, so I'll go back here.
So almost 5 minutes. Let's go for 2 more questions. The first one, Irene, is from Andrea. She's asking, we can see that software is recommending Trina modules. What are the parameters that the software uses within the database to suggest different brand of modules over another? So what are our standards in that term?
Okay, so regarding equipment, this software will just suggest a module, okay, but we have a huge public database where you will find different models from different manufacturers. So the idea is that as the number of designs per project is unlimited and you can try many iterations, the idea is that if you are working with a specific model from a specific manufacturers, is that you select that specific model from our public database. In case you cannot find that specific model, you can upload your own models, inverters, and structures in a private database also. But the idea is that you select your own model. As I was saying, the software will suggest one by default, but the idea is that you can change that model, so you can work with your own models or with the one that you need for the specific designs. But as I was saying, we have a huge public database, so you can try different models from different manufacturers, and you can also use your own, of course, in case you need it. Okay.
Thank you. So on to almost the last one, I think. If we have more time, we can have one more question. But from Frank, what is our timeline to have documents in German? I can go ahead and answer that, Irene.
Okay.
So we're hoping by mid-November you'll have the ability to download all of our documentations in German. And for those who don't know, we actually have currently the ability to download all of our documents in 8 different languages. So you have English, Spanish, Portuguese, Chinese, Japanese, and Italian, and German will be one of them very soon. So one last question, just going back to the previous question from Ulrich about the standards of the documents. So actually, they were specifying what standard we're following for the selection of the documents rather than the standard we're following for the documents themselves. So, so what are the selections of the documents?
So when you are asking about the standard of the documents, like the like how we are standardizing our documents like this. Okay, so I think this is like a decision from the product team and the UX team. So so yeah, it's I think it's based on what we have seen, based on studies, based on how could we standardize those documents for presenting them to I don't know, to different tenders. So based on on our users' experience and on what we are expecting from the software, that's how we are standardizing our documents and the format of the document. But I think one of the most important points here is that all this documentation it's in an editable format. So in case you would need to standardize your own documents or to adapt them to your specific needs or standards that you are using in your company, you can of course download them in an editable format. So that way you would be able to adapt the results that the software provides into your own specific formats. But basically it's based on the user experience that we have collected from them, and that's how we are standardizing these documents and the format. Okay.
Thank you so much, Irene, and thank you all for joining us today. It's really a pleasure, and we hope you found this as useful as we do. And thank you so much for the questions again. For those that we were not able to answer them, we'll be 100% answering you back very soon. So for any questions or any more information, just email us. We'll be very happy to assist you and carry out the conversation. Thank you so much for your time. Thank you, Irene, for the great presentation.
Thank you. Thank you very much.
Thank you, everyone. Have a very nice day. Bye.